Today, I'll be presenting the first part of our webinar, and then I'll be handing over to a guest presenter, Alex Tohidi. He is a generative design consultant at Humatech, a regular presenter and speaker at the Dynamo user group, and he lends his expertise to numerous companies with the generative design solutions. So an overview of our agenda for today's webinar. For the first 15 to 20 minutes, I'll just be providing an overview of how we got to generative design over the course of the last 40 years. We'll be talking about outcome-driven design, which is how the software will benefit your business. Then I'll take you over the generative design framework and the workflow in Revit 2021. And then we'll be handing over to our guest presenter, Alex Tohidi, and he'll be doing a bit more of a deeper dive on the engine Dynamo that powers generative design for Revit. So let's start off with the progression, where we've sort of come from and where we're going. Years ago, before we really started using computers in the architecture and engineering space, we were more artisans. We were working on the drawing boards, working with rotary pens and butter paper and trace paper. In the background, while this was going on, there was the era of computer-aided drafting, CAD, which actually started back in 1957. It moved more into mainstream in the early 80s. Here at Autodesk, we released AutoCAD, and this is where it started to progress, where most companies started moving into computer-aided drafting by the end of the 90s. So this was the first era of 20 years where we started with digitizing our workflows. For anybody who's been around long enough, this is how AutoCAD 1 used to look. It was like this for a number of years, and it had this typical starting point of a ribbon display. In the late 1990s, 2000s, we started to move into building information modeling. And now building information modeling is more or less mainstream over most practices, where we're working and collaborating between architects and engineers. Ideally, we're sharing that information out to fabricators, contractors, subcontractors, and sometimes even building owners. We now move into the next evolution of the digital transformation, and this is what we're kind of calling the generative generation. A lot of students who are coming out and graduating are coming out with programming and scripting skills. Just like how previous generations came out with CAD skills and BIM skills, this new generation is going to be reliant on visual scripting. So with that, we just wanted to run a quick poll on who is here. So what I'm going to do is just start the first poll, and you can choose from the options. So we just need to double check that it's showing up. Okay, so people are entering into the poll. So we'll just let this go for about 30 seconds, 45 seconds. And we can see here, there is a lot of Revit users, fantastic. Some AutoCAD users, which is really interesting. Not as many Dynamo users, and a few generative design for Revit users. So I'll just let it run for a couple more seconds. I think we have most of the responses. Excellent. Okay, so we can see that 75% are Revit users, which is fantastic. 19% are AutoCAD users. And then there is 2% of Dynamo and 2% of generative design for Revit users. Okay, so moving on. So what are we doing with this platform? We're trying to get towards what we're calling outcome-driven design. So in the architecture spaces or engineering spaces, there's a lot of external challenges, especially with the way projects are run these days. There's a lot of complexity, and this can eat into our profits. There may be differences with the scope and variation, the people we have on the projects, who's going to be on the project, who may leave the company, and then the expertise may be dispersed between offices or different countries. There's also a number of issues with resourcing projects and having process inefficiencies. Sometimes the process can still be very manual. There can be issues when you hand the data off to other users, and then there's issues with change management. When we move into things like decision making, we need to be efficient on those decisions. Sometimes you've got to rely on certain centralized expertise, complex systems, or variation on project goals. And then the delivery expectations are changing. For those of you who have been in BIM for a while, certain countries have mandated the use of BIM, like the UK did it in 2016. The way we deliver the projects as well, depending on the procurement route, fast-track project delivery, or there may be responsibilities or legal issues with those responsibilities, especially if you're handing over the BIM data at the end of the project. So what's happening with the trends to address some of these challenges is more and more users have moved into using collaborative tools, working from home, of course, working at physical distances in different countries. We're becoming more and more a mobile workforce. There are a lot of emerging technologies, such as Dynamo and other visual engines. We're trying to launch these new platforms where we can use them for automation, form generation, working for analysis and optimization, and eventually moving into machine learning. Other things that we're focusing on as well is sustainability solutions, which also these technologies can be used for. And then trying to address some of the changing roles and responsibilities, especially when it comes to working to newer standards like the ISO 19650 framework. So for an example of an architecture firm, looking at your profit margins, when we have a typical fixed fee project or maybe an hourly rate, we want to try and negotiate a decent amount of the fee at the front end and then make profit off it. So the key thing here is to be really efficient with your workflows. There's a lot of things that take a lot of extra hours where you're working late at night, you're working your weekends. You want to be more efficient with those long-winded processes and add value to your workflow. So here's some examples of a couple of users who have been doing this already using Dynamo scripting. This is one from Artem Bioko. It's a LinkedIn learning course for an engineer who would be doing a structural frame, typically with the trusses and the beams and the columns and the footings. This could take maybe 1 hour and 2 minutes to manually make in Revit. This particular expert has set up a script which does the same thing every time, but it will do it in 1 minute using a Dynamo script to drive the geometry in Revit. Another example of a user here in Australia is Paul Winter from Parametric Monkey. He has developed scripts to help with the documentation side of your Revit projects. So he has a number of examples on his website on the tools and the solutions he has. And here is an extract from one of his slides he gave us on how to use the Dynamo player to create work sets, to change lowercase to uppercase and text, to renumber rooms on floor plans. All of this can be done using these scripts, and he's got a time and a dollar amount here, saving 10 hours for your business. So the engine the new Revit Generative Design engine uses these scripts in a pre-generative design space where you load it into Revit using a simple interface. You'll run that script with certain parameters. You'll evaluate that script. So you see how it's going to perform with numerous options. You'll then tweak some of those options as needed, and this will evolve and regenerate. And then when you're ready, you can take that option into Revit as your post-generative design script. So there's a few things to take note here. The engine works with certain scripts that are set to take the input data. You can start to use tools to evolve, like the design space data, see how it's going to perform. And then finally, with that design data solution will be the one that will form your project data in Revit. So some customers who have already started to do this, we do have some of these case studies on our website. This is Stamus, a retail designer doing a bottle shop, a liquor store, where they needed to use scripting to speed up their layout process of the stores. So you can have some walls in Revit, a room area, and your families in the project. You load in the script and then just connect the items to the nodes, and then you can run the script and it will give you 40 different design options based on the parameters we have set here within 15 minutes as opposed to 4 hours. For anybody wanting to get started after this webinar, we have the generativedesign.org website, which is our Generative Design Primer. What's really cool here is you get access to additional scripts, which you can use inside of Revit. So under the welcome screen on the left here, you have sample workflows, and it has sample workflows for architects, mechanical engineers, structural engineers, and the like. Another good resource here on the right is finding what you should be looking for when you want to perhaps hire or contract out a generative design designer. So even if you don't have internal staff to develop these scripts for you for your particular projects, you can work with a generative design person on a contract basis to develop this to help speed up the efficiencies in your business. So I'm just going to quickly take you through the interface, what you actually see inside of Revit Generative Design. And then Alex will take you through the engine and show you how it actually works in the back end. For those of you who have joined who might be an enterprise customer or you have an AEC collection, Revit 2021 Generative Design only works with the collection license, or if you're on an EBA. So just a quick note here, there are ways to work it if you don't have the Revit 2021 Generative Design platform, which I'll show on a couple of screenshots in a minute. So for the heavy Revit users who have maybe tried scripting and found it a bit overwhelming, what we've done here is we've made it really simple. So we have 2 buttons in the Manage tab of Revit. One is called Create Study, and the other one is called Explore Outcomes. Out of the box, when you have this installed, you hit Create Study, and it's going to pop up the study type. So these are the 3 that we have when we first launched it. We now have 6 different study types. You can also load in your custom study types here as well. And there's a workflow on how to do that via Dynamo. For a particular study type, which Alex will do a deep dive on for a workspace layout, all we need to have is a room and a family in the model. So all you need to do here with the defined study is select those items in your Revit model and then choose the variables and the goals. So desk rotations or the spacings. A lot of this can be customized also more in the Dynamo script, but you can choose these metrics here and then hit generate. From here, the tool will go through and explore the outcomes. So this is like the framework that I showed in the previous diagram. We're now exploring the outcomes. So what it does is it goes through and does all the options that you're prescribed. So this one was 10 options. It's tracking the studies here. And then down the bottom, we have filter and rank results. So these are the things that were in the metrics in the first pop-up. So we have the desk row rotation, the spacing, the views to the outside. You can go and grab these components here and then adjust the sliders. So if you want the spacing between rows, this one is shown in feet. If you want it to maybe all be a lot wider and be between 13 and 15 feet, you can grab the slider here and drag it to that part of the filter, and that will reduce the options. So some of them are doing it with 11, 10, 12. We've got 10 options here. When you go and adjust this, this will reduce it down to say 3 or 4. Over here on the right, we have a thumbnail with the one that was selected here. We can then look at the goals that is provided in the outputs. And then when we're happy with it, the one that we've optimized using the filters, we go create Revit elements, and that will load it into your Revit environment. Now, if for some reason you can't get this to run when you start it, you've got to make sure you've signed in. You've got to make sure you have access to a Generative Design license. If you're using a previous version, there are ways still to do this. You can go to Dynamo, you can open the script, you can make adjustments to the script. You do need to work with certain components of the script to get this to work. You just need to then go and hit export for Generative Design and then use the same two tools that are in the Revit interface to create a study and explore the outcomes. So you'll still have the functionality, it will just be via the Dynamo interface here. This is some of the stuff that will pop up when you export for Generative Design from Dynamo. If you're missing packages, it will pop up and notify you. So if things aren't quite right, it'll tell you before you send it to the Revit environment. It also saves it to your user profile. So once it's in there, you'll be able to see it again. And then there are just other things that you just need to go through here before sending it up. But you don't have to add in everything. So you just export that, and that becomes available as a study to run in Revit. So you're going to have the same experience. You just need to select those options, those elements again, and you can run it and explore it. It's not going to do the same thing when you come to generate it. So for those of you who use Dynamo and Revit, you'll run it, and I'll be doing it in Revit in the background. At the end of it, it will create the studies, but you're going to have to open it in Dynamo and then run it to generate the final option. So that's just a little workaround if you're not on the Generative Design for Revit 21 in the AEC collections. We do have a number of people on this webinar today joining us from all around the world. It is available in 14 languages supported by Revit. And if you need help, we have a whole new section in the Revit help menu, Generative Design for Revit. There are videos, workflows, everything to take you through getting started. And we have some other things on the primer for more advanced customers who have been doing interesting things like master planning housing estates. Potentially this can be set up using the platform as well. Just to wrap up, for me, there's just 3 new study types that have been added. We did start off with 3. We've got grid object placement, randomized object placement, and stepped grid object placement. And if you need to look at more on the sample files, we now have community files. So we have authors providing solutions here. And this one is looking at a site context and zoning boundary created in Revit, looking at indoor daylight and photovoltaic potential. And another one for maybe people doing a landscape bit of architecture. There is an entourage placement exploration tool as well. So there's a lot of stuff here to help you get started. Okay, so before I hand over to Alex, one more poll. Would you like to be contacted? So a simple thing like, would you like to be contacted by an Autodesk representative? to know more about this product, do a bit more one-on-one Q&A. You won't be bombarded by any marketing stuff. I know I can see there's a lot of people saying no thanks. It's more just to see if you want to have a chat and learn more about the product. So I can see we've got 30% saying yes, that's great, 70% saying no thanks. So it is just purely to help you with your generative design workflows. Okay, we will move on from that. Thank you for giving us that feedback. Okay, so with that, I will now hand over to Alex Tohidi. I will make him the presenter. Alex is a guest presenter today. He doesn't work for Autodesk. He is an independent design consultant, and he has kindly agreed to work with us. And I'm just making Alex the presenter.
Hello, everyone. I'm just trying to see, like, just give me 1 second and share my screen with you guys. So now
We can see the shells.
Just give me, stop sharing my webcam.
The shells
So you,
are done.
You can see the shells, right?
We just need to
start the slide. So that's
yep.
what I've been. Hello, everyone. Before I start jumping to the workflows and solutions that we have developed, I need to thank Autodesk for providing this opportunity. Sam, Adam, and Elena, and Martin, everyone from Autodesk Australia. They've been doing all the hard work in organizing this webinar, and yeah, greatly appreciate it. You can reach to me via this email on the screen, or
Alex, we can't see your screen, I don't think. Yeah, you need to share your screen. Excellent.
So, okay.
Yeah.
So,
thank you.
Yeah, so my email here if you need to reach me, and my LinkedIn profile there. Just to start. Okay, about me, just a really quick way of who am I and how do I operate. Like, I'm an electrical and computer engineer, been providing training for Dynamo and Python within different organizations. I would be happy to assist you in that sense. And I work as a contractor because, as all we know, projects as construction projects, there are a lot of people involved, and this type of workflow, you can't really get it up the ground unless you have people who are familiar with the workflows and, like, dive in. So people who are interested in this type of work. Team if you need to. So my interest, system implementation and automation, and geometry and data. So this is an example of a harbor bridge we developed using Dynamo a while ago now, like it's almost 3-4 years ago. Okay, the agenda of the this webinar, like I will give at the beginning, I will give a quick introduction to Dynamo and generative design for almost 5 minutes, complement to what Sam told, and then to move up to examples, we have this imaginary urban context, and then for the first example, we run building massing about 5 minutes. For the second one, office layout about 5 minutes, and at the end, we talk about building facade. The overall theme of these examples are sustainability, and there are 3 examples which are, each of them are going to take about 3 minutes. So performative facade is the first one, shadow study, and optimal fill angles for the facade. And then we have a question. And just one thing to know that there is a lot of context here, and I have like very limited time, so I wouldn't be able to cover everything. If you need to, if any of this workflow jump out at you, then please reach out. We can have a conversation about it. Okay, why Dynamo? Dynamo is a common data environment. Unlike traditional CAD drawing that user has to draw things manually, it gets The geometry get defined based on data and algorithm, essentially. As you can see here, data is passing through the nodes, and then you connect the nodes here and output there. So it's essentially a data structure. It has link, you can process the data, post-process the data in Python or many other languages. So it's really powerful in that sense. More about why you should look more into Dynamo, because as we know, Revit is a very rich repository for labeled and labeled data. Like a lot of users sit there, put elements manually into Revit model, and we can extract geometrical data and metadata from those elements within our Revit model. So it's quite powerful in that sense. Essentially, it's written in C# languages, but there are differences between C# and Python. If you need to know more about it, I can be helped. But the good thing about Dynamo is like it's quite high-level visual programming. Like what it means is like it's quite fast to develop complex solution in Dynamo. And opposed to like actual coding, but it has downsides into it. Like the amount of data that you can process, it would be a little bit less. So like there is always an option that you can go into code or do it in Dynamo. But what I found is Dynamo is really quick, and at least it's very good for prototyping systems. And then like once you are happy with it, you can go further and implement things further. So you can also implement like artificial intelligence and machine learning within Python environment. The solutions developed in Dynamo can be shared with others. It's a teamwork, as I said, because like people need to know how the Dynamo operates, or at least know the underlying logic behind it, so they can operate on it. It should be viewed as a project, the development of the Dynamo, because it requires resources. It requires like whatever is within the project. Like you should see system implementation as a project essentially. It's not easy, I said that, but it's very powerful. So your call. Well, to develop things in Dynamo, essentially system engineering and helper diagrams, you can use various sorts of charts like flowchart, class diagram, work diagram, and this type of things to build up your logic first, and then go on with your implementation system. For example, this is a Dynamo use case that we developed for a structural engineering firm, BG&E, in Sydney, Australia. This is a system implementation in opposed to actual project-specific solution. What this solution does, like the tools used are Revit, Dynamo, Excel, and Python. And essentially what it does is get the geometrical data of each structural columns out into the, Python and Dynamo, and then process it to calculate the total tonnage of the used reinforcement within the Revit model, because each column has an instance parameter, and reinforced bar types is saved within the Revit model. So we have the bar diameter, we can calculate bar lengths, bar laps, and all that stuff, and then calculate the total tonnage. This will save a lot of time for this firm. Like just like in general, you say that they would put an engineer onto this, and then like it will take a day or two, but like we can generate the result in 10 minutes. I mean, implementation of the system was time consuming. So. Another example, this is a Dynamo use case for project-specific geometry kind of thing, if you like. This is a wave formula. Because we work with logic, you can kind of calculate quite complex mathematical solutions into this. So this is essentially a wave formula, and I generated the design, and I was happy with it, so I 3D printed it, as you can see here. I'm just gonna quickly show this video to you for those who don't know much about Dynamo, to explain how things work. So it's a parametric environment. So for instance, here, as you can see, I have a phase defined for my wave, the frequency defined, amplitude of the waves, and the center. So as you can see here, I'm changing the frequency at the moment, frequency of my wave, and it should change the geometry to reflect on this. So it can generate a lot of solutions. This parametric nature of Dynamo, it allows us to create a lot of different solutions. As you can see here, I'm just moving the center point of my wave So you can see it's quite flexible in that sense. Why I'm showing you this? This is because this is very important in knowing how generative design essentially works. So moving on. Before I go into generative design, like it's quite important to know the requirement gathering is very essential in system development. Like you need to know what is the system, what is the expectation from the system, what's the objective of the system, or is it ever going to be used if we implement it, or it's not going to ever be used. So this type of conversation has to take place prior any implementation, I believe. In generative design, in a nutshell, like how do I describe it, is first you have to have a parametric model that you can generate a wide domain of designs. So we call it design space solutions. And then like you gotta have some sort of goals to measure the performance of the generated design and evaluate it. So like you essentially iterate through all the solutions that Dynamo can generate for you. And you're like, okay, this is good, this I don't like, this I like, this I don't like, and then like kind of check them against some sort of performance design, check the performance of the design against some certain goals, and then select a handful of the best performing solution and hand it to the designer. So it essentially doesn't do the design for you. Like underlying logic and everything has to be built prior moving to that. A little bit, like I won't talk much about this, but this is evolutionary algorithm, one method that essentially help you to select the best performing solution. It's what it does, it's like you get the surface of the solution and then like it's essentially get the derivative of it. Like think of it as a how rain find its like how rain goes. If it's raining on the surface, it finds always the lowest point and it goes that way. So this is essentially how evolutionary algorithm works. Like it could be single objective, there's only one goal you want to optimize, or a multi-objective algorithm. The danger of local minimum has to be considered. I'm just gonna leave this at here. Have more conversation with me after if you need to. Okay, going to this imaginary urban context that we have designed, like building massing, and I'm just going to go through the example in this. So the first example here would be building massing. So this is how Dynamo looks. As I showed you for this particular example, this was done by Autodesk team, pretty amazing job. Parameter to be used in generative design. So like the objective of this study is to find the optimal performing envelope for the tower. So you define certain set of parameters. I'm not going to go through all of this, but you can rotate the outer box of your envelope in different angles, place them in different angles, and then like for instance, if I go to the next slide, this is what you will have like total cross square meter of gross square meter of your tower. Which is built of retail and offices space, and then like you have a percentage here, and as you can see, it goes from there. So what we are going to do is like we set this specific parameter, the retail ratio, as an input to our generative design, and we generate many goals. So like it will become more clear as we go through the slides. Just bear with me there. So for example, for building massing, we need to have a matrix like that kind of value and input to the system, because for instance here, like for office matrix, like we have cost per square feet, floor to floor height, and you can change this because of the parametric nature of the Dynamo, and your model, Revit model, will update. So revenue per square feet per year, for instance, this is for office spaces, and all this other type of the parameters here. So we essentially use this matrix, and the same goes for the retail. We use this matrix to generate, to evaluate the generated solution within generative design. So the purpose of this slide is just to show that like Dynamo is pretty good for coloring. You can transfer geometry between Dynamo and Revit quite easily. So these are native Revit floor elements. So as I said, like we set this as an input to our generative design. I want to find the optimal ratio of retail space to office space to maximize a certain set of functions. So for instance, in this particular example, we have to define a mathematical function. Some people call it fitness function, to calculate the total amount of, for instance, for this one, to calculate the total amount of value generated per year in a retail block, and then calculate value generated per year for office block. So this is the overall matrix. As I said, for the, various parameters, you evaluate the solution. So here, like one output to our generative design is years to pay back. So that's get calculated. This is the this is the interface that Sam talked about. It. So you certain goals you want to maximize, certain goals you want to minimize. You can even limit or constrain your input. Like I don't know, like it might not be the case that you want 90% retail project over 10% offices, so there would be a logic limitation that you can apply. So this is what you get, like different type of angles of the tower. So I'll just quickly show the video. It goes for a minute. Masses are collected in Revit, and then, like as you can see, the floors are generated based on the parameters that I showed earlier. So how to get this solution into Dynamo? Well, you right-click on this and set this as an input here, as you can see. So this would be an input of our study, and the output. There are a bunch of parameters here that you can right-click and, for instance, years to pay back. And then this is set as an output, and then you run your generative design. And various solution will come up. As you can see, you have a dotted plot down here, so you can see, and you can assign y-axis and your x-axis. So for instance, the ratio for retail is my x-axis at the moment, and my y-axis is the total value. So like this is if you press on the filter, this type of diagram, you can actually filter the parameters that you have defined. You can even move them left and right if you want to, and then like constrain your goal to sort of the limit that you need to know. One thing to note, so I don't think this is really ever going to get the point of the designer, but it definitely help them to make informed decisions. So as you can see, like all the parameters getting evaluated for each input here. So total value, total cost, and everything for this is calculated. Let's move on to second example. This is a test with algorithm. Underlying algorithm for this is somehow a little bit different with the other graph that Sam was showing, but essentially it's the same thing. Tools used in this is our Revit, Dynamo, Python, and Generative Design. If I go one slide back, and it can be, the users are like interior design. To name a few possible use cases for further development: car park, hospital beds, casino tables. And because what essentially this workflow does, I'll talk about it later. So this is our urban context, the same urban context that we are working on. So on a specific floor, like this is level 31 of that tower that I showed, we draw a field region. So in Revit, as you know, field region it's quite flexible, and then the algorithm lay down the workstation algorithmically, if I can say that word, and then like as you can see, it's quite flexible. Like we can tweak the algorithm to have a desk sitting back to back or front to back, and then or a single row of desks. It's quite flexible, like a field region. You can allow for paths, you can draw it whatever you want, and Yeah, so let's move on. Like what you have to do is like go into Dynamo, select your modal element, which in this case is field region. You can allow for amenities, meeting room, reception area, and so on, because it's a quite flexible boundary. So you just select that, and then this workflow is working within Dynamo, not using Revit Generative Design. And you select the family that you want. I mean, of course, it has to have certain parameters, this family, because instance parameter of this family getting like it's driven using Dynamo. So if it doesn't have that particular parameter built within your Revit family, you might see a little bit of problem there. So it lays down the desk in this fashion. You might say, oh, well, like this is a lot of desk and stuff. I mean, like you can always cut a bit in the middle and modify your field region to suit. But what are the parameters that we are using in this instance? Well, I'll go through them because like one parameter would be depth of the desk here, as you can see, and this is Revit, this is Dynamo, and you can see this value is driving the instance parameter of this object, and the clearance of the desk from the one next to it. This is interesting because it allows for social distancing rules, and you can have a specific requirement of how far you want to sit, a person sit to the next person. So depth is one parameter, length is another parameter, and distance between the desk is another one. So you can totally adjust this because these are just numbers and you can change them. One thing I wanted to show in the previous slide is like you can see the instance parameter that is getting filled up using Dynamo. There's a height parameter if you want to have a stand-up desk. Well, it doesn't have obviously any impact as far as we know so far. It's like it wouldn't have any impact on social distancing, but it's just something that is built into the Dynamo graph. The most important parameter that we're going to use is angle parameter, because the objective of the study that we want to run is like what is the optimal angle, like what is the angle that, like, giving the certain set of rules that we set up using social distancing, what is the optimal angle to give us the maximum number of the desks on the given field region. This doesn't like, it's one thing to important to know, like this is this doesn't essentially design a floor plan for you. It's still everything full control in the hand of the designer to draw the field region where they need it to be drawn. So as I said, this is an input parameter, and then the output is total number of the desks that we want to maximize. So right click on this and set it as an output. And then, as I said, this solution doesn't consider connectivity, view to outside, personal space requirement, adjacency of one desk to the other, to another, or privacy for the desk, clustering, tenant requirement if there is one, or distance to exit. So these parameters are not currently considered in this study that we are running, but they can be built. So as you can see, this is very quite simple. Like all I'm checking is angle in degree, and once you run this in Dynamo, you can't really select this stuff. But like I'm selecting the randomize, so it's assign a set of a 45 random number. And then because of this particular shape, the study yelled that 76 degree is the optimal angle that I can have the most number of this. It's kind of like in line with the angle of this wall here. So draw that, select your field region, set it to output. This is input. I might fast forward, running a little bit short on the time. Okay. And then it gives you the optimal angle. Like, I mean, evaluate the function, which is the total number of the desks. The third example, I have 7 minutes. Very quickly, I'm going to go through this. Building facades, so climate emergency and sustainable design. So we can use computation to design things passively. This building is just like because of its natural ventilation, sort of that allows for air to flow the building. So for this, what we have done, like we have used an environmental analysis tools called Ladybug, Honeybee, and Butterfly, Dragonfly. Well, I'm not gonna cover much about this, but if you need to know more about this kind of platform, which is getting linked into Revit, Dynamo, Grasshopper, Rhino, we can talk about this. So this is an example of the very first example, like it's an example of performative facade. This was done with architects, with architecture firms in Sydney. This is the Revit model. We got the Revit model, massing of Revit model, ran the radiation analysis on it, transferred the geometry into Rhino, ran the radiation analysis. As you can see here, this is the part of the building that get the most amount of sun, and on the corner we get not much. But moving on, what we ended up doing is like we defined a parametric paneling system that the opening of each panel is kind of determined by the amount of the sunlight radiation that that particular panel get. So they were able to make informed decision and data-driven decision, essentially. So this building that you can see, the render has been done by architects, like it's kind of performed the best under this sun radiation. So this is one example. The other one is shadow study. Well, there is a requirement in Australia for how, what's the minimum requirement for sunlight. So I'll just reading through the number one: living room and private open space of at least 70% of apartment in a building should receive a minimum of 2 hours direct sun between 9 and 3 p.m. at midwinter in Sydney metropolitan area. There are more into this. I'm just gonna pass over. So like, it's just know that like, what are we running this study for? The context was brought from Revit into Rhino, and then we set up the analysis period. As you can see, the shortest day of the year. That's how sun sits above Sydney. Tools used were Revit, Dynamo, Rhino inside, and Ladybug. So this is a Revit model on the left, and on the right, it's the Rhino model. Using Rhino inside, I was able to bring the geometry of the Revit into Rhino, data interpretability to this highest. And what I ended up doing, like just like all the detail came through and run my analysis, knowing how much sun each area gets, and then selecting the boundary of the mesh here and generated Revit native element. As you can see in this example as well. So Revit here on the left, and then on the right, as you can see, because overall what we were doing, we were measuring the effect of the proposed tower on the existing tower. So the red one is how much sunlight they get at the moment, complying with ADG rule, and the green one is the area that receives sun now after the proposed building is built. So it's kind of a comparison. As you can see, this is all brought into the Revit as a native Revit floor element, can be scheduled and everything. Another option was to bring it as a massing option, or as you can see here, the green area, how much sunlight we get after the building is built, and orange, how much we get after, or vice versa. Okay, the example C is optimal fin angle. As I said, parametric design is quite important. This was done in Grasshopper. Like angle is one parameter, number of the fin is one parameter, fin depth is another parameter, and rotation angle is one parameter. So we are able to generate a wide range of designs, and then measuring the effect that sun, like how much sun or how much radiation is blocked with that particular vertical fin in this case. And like, as you can see, this is improving the performance of our space by 15% almost. The same goes for horizontal one, as you can see. So it's this is just a parametric definition of the space, can be done in Dynamo as well. And then like we calculate the total solar gain of the space and run the analysis there. Why this is included in generative design? Because there is another option like called there is another plugin. Well, it's not plugin. Essentially, there is a node in Grasshopper called Galapagos, and what it does, like I'm changing the rotation angle of each fin evaluate a certain function, fitness function, and then that way I can calculate the optimal angle of the fins, meaning in what angle should my fin sit to work the hardest in terms of blocking the sunlight. So to bring it back into our context model, a speckle was used, in this case, not Rhino Insight, to transfer the geometry from Revit to Rhino, run my study here, measure the sun gain, and then find the optimal angle. As you can see, all the 4 elements are coming through here. And then, well, you might come up with something like this. As I said, like it might not be the final design that you want, but hey, you can always go back to your drawing and then change them, evaluate them again. And then at the end, like I was able to bring the result back into Revit using adaptive component, Dynamo, and a speckle. So like essentially a speckle is a platform used to transfer data. Instead of USL, it's like kind of like a flex, what it used to be. It's set up a URL, you send the data up, and then you can pull it down when you need to. The last thing I wanted to say, like about optimal field angle, but like remember, like we can generate this generative design platform, this parametric design platform allows us to generate many different solutions, and then we can create a wide domain of design and evaluate them and come up with the best solution that kind of perform. On the last note, like you can come up with quite complex geometry using this type of methodology. But what is interesting about this type of geometry is like it would be a continuous flow of data if you're gonna ever build them, like because every piece would be different. If you wanna go down the path of digital fabrication or so, you gotta always consider that this type of workflows is a continuous flow of data. Otherwise, you can't really model this stuff. The last, I'm 1 minute over my time limit, but the conclusion, well, I think power of parametric design to Dynamo and Grasshopper are somewhat underestimated within the industry. What can be done within that space, especially in infrastructure project. And so it's about the concept, how I see it. Like it's not about the tools, like it's not Dynamo or Grasshopper versus what, like it's just about the concept, like because these tools talk very well together because they're data driven. Data modeling should be viewed as a project, hence resources, I talked about this, teamwork, I talked about this, and further data analysis can be done on the data here. So this is me, and I'll just hand it back to Sam now. And I'm open to the question. Reach out if you think I can be a help.
Thanks, Alex. Yeah, thank you so much for doing a deep dive on some of those workflows. I know there was a lot to get through. For those on the webinar who wants to ask some questions, we have the question box inside of the GoToWebinar engine, and you can type in your questions, and either myself, Alex, or one of the Autodesk staff will endeavor to answer them. If you need to dash, we do have our email addresses up here on the screen, so feel free to take it down and drop us an email directly. Okay, so we have a question here. You mentioned infrastructure applications. What examples can you recall? So infrastructure, we do have Adam Walmsley on the call. Adam, I wondered if you'd be able to maybe discuss some infrastructure applications.
Yeah, sure, Sam. So Alex was talking about using computational design methodologies for infrastructure applications. Some things that would apply to that include bridge design, for example. So me personally, I've been a Dynamo user for a little while. I've used Dynamo to sort of select all of the bridge girders in a bridge model, for example, and then automatically count them and add mark values to each of those planks in the Revit environment. You can use Dynamo for rebar modeling if you are working on some bridge projects or that type of infrastructure. You've also got Dynamo for Civil 3D. So that plays right into the civil infrastructure type of project. So you can start to work with pipe networks, you can work with road alignments, surfaces, corridors, things like that. There's a Kogo points is another good one. So yeah, there's quite a lot of applications out there that you can apply not generative design, sorry, you can apply computational design processes to infrastructure projects.
And just following on from that, there's another question. What's the best way to learn Dynamo for a structural engineer?
I've answered this question a lot. The Dynamo Primer is a great website to go to. So if you Google the word Dynamo BIM, it'll take you to the Dynamo website. We have the primer there, which is a really good, thorough document on what Dynamo is, how the nodes work, and understanding the logic behind the way that the data flows inside of Dynamo. From there, we also have the Dynamo Dictionary, which you can access from the same webpage from the Dynamo BIM site. And that goes in detail and explains what all of the nodes are inside of Dynamo. The Generative Design Primer is slightly different to Dynamo that you've got there, Sam.
Okay.
Yeah, the Dynamo Primer is a great read.
Yeah, we have primers for all our products. So yeah, as you can just Google Dynamo Primer and it will come up. The next one is a question about generative design used for supermarket layouts. Yes, David, that can be used. This is a customer example here. This is Stamus doing a layout of a smaller version of a retail environment, but yeah, it can definitely be used. Next question, just for time, can this be implemented in a single-story house designs? Yes, it can be used anywhere. I've even seen an example of users doing this for a kitchen design and automating the layout of the cupboards. Next question, does Dynamo and creative design, is there an application for MEP design and modeling? Yes, so just to add to this, you can go to the generativedesign.org and this will fire up the website. And for anybody wanting to learn about some examples, here in the sample workflows for MEP workflows, we have some kickoff ones just here. So yes, it does work for MEP design and modeling. Dynamo, okay, what about generative design? Just skip forward a little bit. So how flexible is generative design for doing other workflow and studies? So for questions like that, I recommend that you talk to a generative design expert like Alex. Basically, what they do is they can customize generative design scripts and they can ensure that it runs the way you want to work for your particular workflow. So again, Alex's details are here. As you saw in his presentation, he can go very deep on the product. He knows a lot about it. And a lot of this can be implemented with the help of a generative design expert to customize the scripts. Or if you're a Dynamo user, you could potentially customize the scripts as well and then use them throughout your practice. So just the final question, and this again will be for Adam. Any example of generative design in structural engineering?
Yeah, I've seen examples where you can optimize the cantilevers from columns on a building facade. So if you've got a floor plate, you've got a grid of columns and you've got a curved slab edge, you could use generative design to analyze the geometry of the floor plate and I guess, minimize or maximize the cantilevers that you can work with from that perspective. That's one idea that quickly comes to mind.
The other thing I can think of is like membering optimization size. Like, what is the like you for instance, like what thickness of the beam it need to be, or like how much, what's the optimal member size as well.
Sam, are you there?
Yeah, I am here. Like, I don't know, like talking
I think
was kind of like,
Sam might have been disconnected.
yeah, perhaps.
So what we'll do is we will wrap it up there, guys. But thank you all for attending today. I hope you guys found that valuable. I certainly enjoyed hearing Alex present. But if you guys want to learn a little bit more about generative design, or Dynamo for that matter, feel free to reach out to Sam or Alex or myself, Adam Wormsley, and we can continue this conversation offline. Thanks, guys. Have a great afternoon.
Thank you, everyone.